All right, let's go. So, hello everyone. Thank you for having us on stage. So today, Salomon and I will guide you through the process of creating a speaker deck using Compose multi-platform. I will start by diving into the different steps of how to code a basic but functional slide deck just using the Compose API. And Salomon will demonstrate what he has been working on and how you too can start coding your presentation with Kotlin. So let's start with a simple Compose multi-platform project with the desktop target and a custom material theme with our brand colors and fonts. Also, we have a unique composable that contains everything you see in the introduction slide of today's talk. So you may have noticed that the fonts and images are not taking up to the maximum of the space inside the window. So we will start by addressing that. So maybe some of you have difficulties to read the small texts. And beware, I will be using a lot of live templates to go faster because I have a lot of things to show you today and because my defective brain does not allow me to type and talk at the same time. So let's start by creating a container that will be responsible for adjusting the density of the presentation. So thanks to Compose, we don't have to rely on the client size screen resolution, sorry. The density will allow Compose to transpose dimensions, so DPs, SPs, to pixel automatically. Let's start by retrieving the current density from the composition locals, and now we can override it. The density, we can override the density by applying a scaling factor to it. So how do we compute this scaling factor? We need two things. The first thing is a target size, so it defines the aspect ratio on which we want our composition presentation to adapt to. So here it is a 16:9 ratio. And the second thing is that we need to track the container of the presentation size. So we will use the onSize change function to track the box size, and we will put it inside a mutable variable. All right, now we can compute our ratio. So what happens here, every time the presentation size changes, we compute the product of the presentation size by the target size. And we take the minimal value of them to ensure that the ratio respects the window size. So let's apply this container to our presentation and run the application. And run the application. All right. So what did I do wrong? Nice. Okay.
Une compilation fail. Qu'est-ce qui se passe?
Fuck. All right.
C'est bon.
Yeah, c'est bon. All right. So here is. So now you see that the composable elements are taking up to the maximum size inside the window. So I can start building my slide deck, and hopefully this will work. All right. So let's add some structure. So let's add a data class slides that will be responsible for identifying each one of my slides. And obviously, it will hold the content of every one of my slides in a composable lambda. Now I can migrate my introduction slide as a variable of type slide, which is named intro, and the content remains the same as before. Now I can complete my slide deck by adding some other slides, or an agenda slide, which is a column with some text, and a conclusion slide, which is also another column with another text. So you may be aware of how Compose works. One thing we can do to start a recomposition is to observe some state. So let's start by creating a presentation state that will hold all of our slides so we can navigate through them, and the current slide index on which will be used to display the current slide. All right, let's now declare and initialize our state. So we need obviously a list of slides to instantiate it. And finally, I can display the current slide content. All right, so if I run the app, this should work, and we should land on the first slide, so the last one we saw earlier. But what I expect from a presentation is to be able to go forward, but even backward on the railway of my wonderful slides. So let's enhance the presentation state for that and make our current slide a private set variable. Thank you, GitHub Copilot. And we need two other functions, so a goToNext function and goToPrevious to go back and forth inside the presentation. So the first is the goToNext function that says if I am not on the last index of the slide railway, I can go forward. If not, I do nothing. And the goToPrevious function that says if I am not on the first slide, I can go backward. So now, easy, right? Now I can just bind those functions to my window on something like a key event handler, so I can navigate through my slides. Let's go to the main. So with Jetpack, with Compose Desktop, we declare our event handler on the window level. So here I expect that I can hit the left and right arrow of my keyboard and be able to call my goTo's functions. So goToNext and goToPrevious. All right, but we got a problem here, as our state is defined inside a lower scope. So obviously I will have to declare it inside an upper scope. So let's assume that our window is aware of our presentation state here. And let's wrap it. And let's create the composable functions that will create our presentation state. It needs a composable lambda that waits a presentation state. So I can now create my presentation state. I also need some slides to create it. So I can add them as a parameter to my function. And finally, I can call my content with my state. All right, and I have to pass my slides, obviously, to my wrapper function. So now this should work. If I run the app, this should work. I should be able to navigate through my slides, but if I want to display or interact with my state in lower composables, I should pass the reference of the state. And if I have many children, etc., I will have to pass this reference everywhere. So I will use the composition local mechanism to make my state available across all my composable tree. So let's create a composable local of type presentation state, and let's provide it inside our composition or function wrapper. Here I can provide the state And I can remove the presentation state from the content signature. And now I can consume my, where is my mouse? Yeah, I can consume my state directly from the local presentation state.current. And finally, I have to adapt the presentation so I can use this composition local instead of creating my presentation state. And if I run the app, hopefully this should work. Still no.
Décidément.
Okay, so Louis said I need to call all the Java.
Là, dans la console. Dans la console. Garde le W pour le moment, stop. Vas-y, réessaye.
Okay. Yay.
Yay.
All right, so let's navigate, or not. So what did I do wrong? Obviously, I am the problem here. So here, the presentation state is not considered as stable by the Compose compiler nor the runtime, else there is nothing observable. So if I change the current slide index, there is no recomposition triggered. So let's change this to a mutable state of 0 and run the app. Again. All right. So Gradle is mad at me today. And we are losing the starting of a daemon every time. Yeah, but I will kill Andrew. Oh,
Still it works.
it works, but yay! So can navigate. So we lose time every time. Okay. So this is a start. This is not as appealing as any other solution you may use to, but I find it a breeze compared to those boring deck builders. Let's enhance our presentation by adding some animation between our slides. So how do we animate our slides? Firstly, we need to iterate over our slides and using the key functions to help Compose optimizing its recomposition cycles. And now I can show the content of my slide, display the content of my slides, and even animate it when the index is equals to the current slide index. I can even add some more animations, some custom animations, so we can add them for the enter and the exit animation transition. Before, we used to create our presentation using Kotlin HTML and then Compose HTML, and it was really hard to animate things as we had to use HTML and CSS. We were really limited, and nobody's perfect. With Compose APIs, we see that things are very easier to animate things, and let's hope something will run at some point. I think there is something running, but it takes really some time. And if I kill Java, yeah, just wait a little more than usually. Okay, so animations are here. I would like my slides to. I would like to have some kind of mental visualization of my slides as a railway, so they should come from the right and go out to the left. Here, they are all are coming from the left and going out to the left. So let's change that. We only need to add a Boolean that says if I am going to the next step, I am going forward, obviously, and otherwise, I am not going forward, so I set it to false, and I can adapt my animation with that. So if I am going forward, I want my slide to come from a positive offset, so from the right of my screen. And if I'm going backward, I want them to come from negative offset from the left. And we can invert that behavior, slide out. For the exit animations, let's rerun that and wait a little more. We are almost there, yeah. All right, great. We have a smooth animation with just a few lines of code. One last thing before I hand over the stage for Solomon. A slide is of no use if I cannot add some steps in it. So we usually add some bullet points that appears one after another depending on the current step. So let's handle this step mechanism inside our slides. Firstly, I need to add a step count inside my slide structure, so it defines how many steps can a slide have. And additionally, I need to pass a current slide integer to the content composable so it can behave accordingly. Now we can add some steps to our slides, so the first slide won't have steps. And the agenda slide will have two steps, which are animated depending on the current step. All right, let's do the same for the conclusion slide, which takes 3 steps, and also some animated content, depending on the step. The step 0 and the step 1, so obviously step 1 and step 2. And let's finish by handling this current step inside our presentation state. So we need a current step index as mutable value. And we can now adapt the goTos function when it's relevant. So when I'm going to the next step, I will check if my current step is lower than the current slide last index, and if so, I can go to the next step. Otherwise, I try to go to the next slide, and here I need to set my current slide index to 0, so I land on the first step of the next slide. And conversely, when going backward, if I am not on the first step, I can go to the previous one. Otherwise, I try to go to the previous slide. And I also need to reset my current step index to the last step of the previous slide. All right. And finally, I can add my state.current step index to the slide content so it can behave accordingly. And this is still not the right command. And wait. Hopefully this will work. Yay! I have some steps with some efficient animations with just a few lines of code. So that's it for me. Give a warm welcome to Solomon, who is eager to demonstrate what he has been working on for the last few months.
Thank you, Robin. So I won't be compiling anything. So Gradle can stay where it is. So what I'm going to show you today is a project that Romain and we've been working on for the past few months. And indeed, it's been in our head, and we've experimented with a lot of ways to do that in the past few years. So this is a Compose framework that allows you to program your slides. So if you can think of it, if you can program it, then you can make a slide out of it. There's a link here. Don't go there, it doesn't work. The library is not open source yet, although it will be in 15 minutes. And the slides that you create, the slide deck that you create, you can export it to the web, and you can have your audience or your internet audience access your slides. As it's not open source yet, the slides aren't online yet, but if you're watching this online, then the link does work. However, in the audience, it doesn't yet, so stay with me and just watch the screen. So this is a simple slide, and it has 2 steps, and it works exactly as Romain has just shown you. So you declare a slide, you declare the number of steps, and then how you display what's inside the slide and how you animate it is really up to you. But a slide is just a function. It's a composable function, which means that we can use it, for example, to display all the slides and all the steps that your presentation provides. So here, for example, I have all the slides. You have a little bit of a preview of what's going on, of what's coming. And each slide has multiple steps. And because a slide is a function of a step, then I can render all the steps of one slide in this overview. So that's one of the benefits of using Compose. Because it's a function, we can use this function in different modes. And there's also, as you can see, an overlay here, and I can access all the slides and all the steps in this list. So for example, I can go back to the intro or directly to the second step of this slide. Okay, so how do you create a slide? Well, this is how you do it. As you can see, this is pretty simple. You create a slide, you give it the number of steps, and then you fill it with whatever content you want, and you may use animated visibility here. For example, you may use animated visibility to animate different steps of your slide. So this is a simple slide. It has 2 steps, and the second text is hidden away by this animated visibility. Note this by here. It exists because each slide must have a unique name. As you can see here in the overlay, I can see the name of the slide, which is simple sources. So by using by, we are attributing the variable name, the value name, to the slide, and if all your slides are in the same package, then you're ensured that all of your slides are unique. So yeah, this is the by, and this is the why it's animated. So, how did I just show source code? Because one very important thing that we wanted in our slide deck framework was a way to animate source code, as you show and animate source code, as you can see here. So I did this. Okay, so this is the regular way a source code is displayed if you do not theme it. So problem is the default theme is, of course, IntelliJ Light. So let me add a white background. So as you can see, all I need to do is add a regular Compose modifier, and then I can add a background, modify the shape, and etc. But yeah, the thing is, this is a dark-themed presentation, so it doesn't go well with this theme. So let's change the theme and change it to source code theme Darkula. So yeah, Darkula works better on a dark background. So that's better, but maybe you saw that the previous slides used a different theme. It's our own theme that we developed, and the first thing we did for this theme is change the font. Instead of using the regular font, we use JetBrains Mono, because I'm used to IntelliJ, so I like my presentation to display source code with the same font. So let's change the fonts. And then we developed our own source code theme. And a source code theme is just a function. I'm not going to show you today how to create your own source code theme. But basically, if you can think of a CSS that you can apply to a highlight.js result, then you can create a source code theme. It's basically a function that takes a class, a section class, and then outputs a span style, meaning a color and maybe if it's bold or italic or all that. And of course, the beauty of Compose is that you don't have to do that every time you display source code. And that's one thing we really wanted out of Compose, is the way to abstract away everything that you always do. So for example, here I have a source code with a theme, a style, a modifier. I can abstract that away in a function that I would call code in source code, and it does all that. So one thing that we really liked when writing our slides with this framework is the way that the fact that we could create our own composables and reuse them and have a coherent look and feel throughout all our styles. And note this language Kotlin here. It's a little tip that IntelliJ uses, so that in IntelliJ, this val answer equals 42 here. All this string will be rendered, will be colored by IntelliJ as Kotlin, so you can have IntelliJ validate your code while you're coding your slide. Okay, so there's one problem here, is that a slide content is displayed only when a slide is displayed. And the problem we have here is that, remember, source code needs to parse your Kotlin, your source code. And by the way, it uses highlight.js under the hood. So it also needs to start a JS engine, load highlight.js, parse your code, apply, parse highlight.js results, and all that can make your slide a little bit janky. So there's a way to prepare a slide and run code before the slide is displayed, and you would do that by using prepared slide. So the way prepared slide works is that instead of giving to the slide the content of the slide, you are given a composable you give it a composable lambda which will return the slide content, which means that you can move the remember source code outside the slide content, and it will be ready as soon as the presentation starts. So you start your presentation application, because it's an application, it's a Compose application, and it immediately prepares the source code. It doesn't show it, but once the slide appears, everything is ready and you don't have a janky slide. So as you can see, I can highlight thing inside my source code, I can appear content, I can move content, I can disappear content. How did I do that? So let's say that I wanted to explain to you how bylazy work. I would show you that this code computes the answer immediately, and that maybe compute answer takes, a few thousand years. So it's better to only access it if we really need it. So I would move it into a bylazy block. And by the way, have you noticed that it's using by lazy and not equal lazy? So I would explain to you what that means. So in this example, I have 3 states. The first state is the initial state with the equal. The second, I show the block. So I show by lazy and both accolades. I don't know how. Brackets, thank you. And in the last step, I highlight by lazy. So let's do that with our framework. So this is how you would do it. First of all, you would declare 3 markers. So markers are the way to animate your source code. Here, I declare 3 markers, and in those markers, I define when they will be shown. So for example, this equal marker, I say that it's only displayed on state 0. And in my source code, I add markups to define sections that will be animated by this marker. So in this system, a section starts with a markup, which is the marker itself, and it always ends with capital X. So here, for example, I have a section of my code that is defined by the marker equal, and that only contains the equal symbol. Then this block marker, I define that it's hidden on state 0, but it will appear on all other states. So as you can see, a section can contain another section. So I have a section here and a section that contains this section here. And this section contains this bilazy, but also this bracket. And you can use a marker multiple times to define multiple sections. So here I have another section that only contains this bracket. And then finally, I define a third marker that says, okay, it will be this section will be highlighted on step 2. So this is how you animate your code. You write your code, you define a bunch of markers, you use those markers to define sections, and then for each marker you define when the section they define will be hidden, or when they will be shown, or when they will be highlighted. So this is cool. This is very cool, and in fact, all source code animation in this slide decks are done with this system. But it's not ideal, it's not perfect, so we are working on an editor. It's a work in progress, but I just want to show you that we are working on that. So here is an example. I can show this example, so I would show the function content, highlight something, change some stuff, so there's something that appears, something that disappears, move stuff around, etc. And I can do all that in this editor. And I can define sections, and I can change section in the editor, and I can say, okay, this is visible, this is not visible, etc. It's not ready yet, we're working on that, but it will be coming in the next, few insert time frame here. By the way, this is an animated emoji, and if you want to add animated emojis into your presentation, you can use this libs, which allows you to add animated emojis inside any composable. So how do you create your a slide deck with this framework? So you add three Gradle plugins. Kotlin multi-platform, because it's a multi-platform project. You add the Compose plugin, because it's a Compose multi-platform project. And then you add the CUP plugin. So CUP is the name of this framework. It stands for Compose Your Pres. And this plugin does a lot of heavy lifting for you, and it allows you to create a presentation project very easily. Once you've done that, you simply have to configure your targets. So you should always target the desktop, because you should use the desktop app to present. But as I've said earlier, you can also target the web and deploy your slide deck to the web. I will be talking a little bit more on that. And then it's a Compose project, so you're free to add any dependency you want. Here, for example, I add the source code dependency because I want to display source code, and it's in a different module. And I also add 2 plugins that I will be demonstrating in a few minutes. And then, because I'm using material, I add the material dependency. You can use material 3 if you want. CUP doesn't force you to use material 2 or material 3. It's up to you, so you have to add it to the dependency. And if you want to add any other type of composable theme, then it's up to you. And then you create your main KT, and a main KT is a really simple function. It's a CUP application which will handle for you the creation of the window, the resize, the fact that the window resizes, the fact that the keys work on this window, and etc. And then you create a presentation, you give it some slides and maybe some configuration. And there you have, and voila, you have your speaker deck. So what are those 2 plugins that you can add? Well, the first, the laser plugin, you've already seen it. It's the plugin that allows me to freely, that's a very bad emoji. to freely draw over the presentation. And the second, you've already seen it also, it's the plugin, it's the fact that I can highlight some part of the presentation. The second is the speaker window. So here, this computer is in mirror mode, so I see everything that you see, but in a regular presentation, I would probably use the speaker notes window. So the speaker notes window shows you the current slide and the next slide. So not the next slide, the next step. So for example, here it shows me that the next step is this laser and speaker window highlighted, but because I'm here on the last step of this slide, it shows me the next slide. It also shows me a timer, because if I don't have a timer, I'm never on time. And it also shows you some speaker notes, if you want to add some speaker notes. And by the way, you can use the speaker window to draw over the presentation, and it will display in the main window. And you can, of course, highlight portions of your slides, and it will also work on the main window. So basically, this is, if you're using two different monitors, this can be a very powerful tool. And once again, because we're using Composable, it's really easy for us to display the next slide. It's just, calling your functions with the right step. So I did write some speaker notes here, and I wrote them in Markdown. So how did I do that? I added some user data to my slide. Because speaker window is a plugin, it's not in the core library, so there's a way to add user data to any slide, so you can write your own plugins and your own themes and have your slide declare some user data that can be then consumed by your theme or your plugins. So here I use speaker notes MD. MD stands for Markdown, and I can write my speaker notes in Markdown. This was a cool transition. So of course, what would be a presentation without some weird, cool transition? So how do you write cool transitions? Well, you define a transition set, which is a cup data class, but inside it, you just use regular compose transitions. So here, for example, I animate the scale and the fade. And so it scales, here it scales, and it fades. And as you can see, it's nothing, we didn't reinvent the wheel. It's pretty straightforward. It's simple compose stuff, compose animation, and compose modifiers. The only thing that you have to be wary about is a regular compose animation has 3 states: before it enters, after it exits, and visible. And in Sidecup, it has actually 5 states, because it can enter forwards or enter backwards, exit forward or exit backward, and then, of course, the visible state. So that's why here we need to change the value of pre-enter or post-exit if we're going forward or backward, because we want the transition to work backward as well. So as you can see, writing your transition between slides is just a matter of understanding how the transition framework in Compose works. And then, of course, I need to apply this transition to my slides. So the first slide, I need to say, okay, this end transition, so when it exits the screen forwards, it will be exit forward or enter backwards, it will be this transition, and the reverse goes for the slide when it enters forward or exit backwards. And finally, let's talk about theming your presentation. So as you can see, we use our own coding theme in this presentation. So how did we do that? Well, we created our own material theme, just like Romain just showed you in the previous section of this talk. And then I added the background color, so it's this dark purple that we use for our brand. And then I added to the presentation the fact that I can decorate the slide content. So by default, a presentation, you don't decorate anything, but maybe I want to decorate the slide content. And what I want to do is, because it's a dark theme, I want to change the content color of everything that will be displayed in this slide. So icons, text, of course, and everything, to this material theme.color.onBackground. So with that, I just created a simple theme for my presentation. And once again, we didn't reinvent the wheel. We didn't go crazy. We just used what you are using to write your Compose application. And once again, this is Compose. So let's create a composable that does all that for us. I don't have to copy-paste that into each of my slide deck. I can create my own theme as a library, depend on that on my presentation, and then all my presentation will share the same theme with a simple composable. Here, code in presentation. One last thing, bonus, you can export your slides to the browser. Let me show you how it works. It's not here, it's here. Okay, so this is the presentation. I'm in a browser, and I can show you everything, and it works. So your users can see your steps, and it works in the browser. It works using wasm.js, so WebAssembly. It has some glitches, as you can see, and also it doesn't work on Safari, which means it doesn't work on iOS, because Apple is working on that, but it's not yet working on it. So yeah, use it parsimoniously. It also has a few bugs, which are due to the fact that Compose Wasm is in alpha. So for example, one fun bug, I select some code, and then I try to move my presentation, and boom. Okay, this is a Compose Wasm bug. It has been reported, so it will get better. But what I want to impress on you is that this is a fun plus to have. This is a way for your users to access your slides. Do not use that as your main way to present in front of a live audience, please. Okay, so that's it for me. I just want, one last thing. Let's open source this library, because it's not open source yet. So let's make it open source. So this first repository is just the library. What I want to impress on you, no.
Okay.
Yeah. So while Romain is doing that, what I want to tell you is that because we're open sourcing live, it's not, the artifacts are not going to be in Maven Central yet. So if you want to use it, you'll have to clone it and publish it to your Maven local in the next few days. Of course, we will publish everything on Maven Central in a few days. And this second repository, cap template, is just a template project that you can use use this template, and then you'll be able to start writing your slide immediately. Yay! So both repositories are open source. Thank you very much. Just 30 seconds of your time of corporate stuff. Romain and I represent Coding Coders. We're a company that provides Kotlin training, Kotlin certified training. We're certified by JetBrains. We don't do only training. We also do consulting and development. We specialize on Kotlin multi-platform. So if you have any needs surrounding Kotlin or Kotlin multi-platform, you can call us. Hey, look at that. Made with Compose. We also do a lot of open source work, such as this framework for slide decks, and we specialize in libraries that compile everywhere Kotlin can compile to. That's it for us. Thank you very much. You have this link. The first link is the slides. The second link is the project. I think that we don't have time for questions, so be sure to come and speak to us right now, or you can ping us, of course, on the Kotlin Slack. Thank you very much, and I hope you enjoyed this library.